All right, let's talk about intersections of sets or events. If they're mutually exclusive, then the probability of both events happening simultaneously, which is at the same time, is equal to 0. There's no chance of both things happening. So if we take a look at this, look at me, look at the color coding. A is for odd, B is even, C is prime, and D is greater than 5. So I got the different colors here. If you can't distinguish between the red and the pink, sorry, there is no pink anymore, it's just magenta. But anyways, if you can't differentiate between those, you're in trouble, but I'll be talking it through. At any rate, look at this, A and B, So these guys, if we look at event A, which is all the odd numbers, it's boing, 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 and then all the even numbers would be ding, 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 and together they have no intersection. So these two sets are said to be mutually exclusive. There is no number that at the same time is odd and even. All right, well, complementary then. Those are two events that not only are they mutually exclusive, but the sum of their probability adds up to 1, which means they cover the entire sample space. And if you can read that, entire sample space, I wrote it here. Clearly that's a tire. And look, the sample space. So it's an entire sample space. Anyway, so what we've got, if we go back to this odd and even, we can see that together they are mutually exclusive events, and together they account for the entire sample space. You add their probabilities and the total probability is 1. So getting an odd number on a die or getting an even number on a die, these two events are complementary because they meet both these requirements right here. Now let's contrast that with prime and a number greater than 5. So if we look at the primes, 2, 3, and 5, and then a number greater than 5 is 6. So we can see that these two events, the green and the magenta, they're mutually exclusive. There's no number that's in both sets, but they're not complementary because we haven't accounted for the 4 and the 1 in the sample space. So these two events do not make up the entire sample space, so they cannot be complementary. Then if we go back to some of the others, we'd say, oh, what about a number could be even or prime, and so we'd say, well, even numbers, boing, 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 and then prime numbers would include the 2, the 3, and the 5. So now we see we have two events that are neither complementary nor mutually exclusive because the 2 shows up in both sets. So anyway, there you go, complementary, mutually exclusive.